Hey, well, welcome to the 2025 Walter Westman Lecture. Uh, this is a lecture that's been sponsored by the Sydney University International House Alumni Association. I'm the president of the association. We have a number of people from the committee that are here. We're delighted that not only they could be here, but everyone else could be here. Um, Well, the Alumni Association, I should say, represents about 6,000 people who lived at International House from when it opened in 1967 until the recent years when it closed to go through some redevelopment. And the International House Alumni Association is spending a considerable amount of time keeping an eye on what the university plans to do and trying to make sure that the redevelopment is done in the most appropriate way. Before we get started, of course, I'd like to do an acknowledgement of country. You can think about where you are, but I'm located in Seattle, Washington, in the United States. So I'm located on the historic and contemporary lands and shores of the Duwamish, Suquamish, Muckleshoot, and other coastal Salish nations. I acknowledge the forced displacement of Native communities from this land while honoring the endurance of the Duwamish people who still live here. And certainly you can think about the indigenous people that live wherever you are located. Couple of, I already said this a little bit, if you could please turn off your mics and turn off your video so that we can focus on, I'll be doing that myself, so we can focus on Randall's presentation when he gets introduced. If you have a question, you want to get it out before the end, you can put it in the chat. But otherwise, we'll open up the mic and the video at the end for conversation questions for Randall. We will ask that you use the virtual raising hand if you can, so that we keep everything in order. We'll keep the order of who's asking questions. But again, you can feel free to put things into the chat while Randall is talking. Again, thank you for being here. What I want to do is to turn this over and introduce Ian Gutierrez, who is the moderator for tonight. Ian is also the member of the SWIHA. That's what we call the Sydney University International House Alumni Association, fondly known as SWIHA. He's on the committee, and he has been very diligent at identifying Randall as our speaker tonight. He's actually already thinking about next year, which is just delightful. So I'm delighted. He attended International House in 1996 and 97, working on a degree in economics. He's worked all over Asia in areas of management consulting and communication in high-tech industries, and in the financial sector. So that economics degree obviously did him well. I'll let him say a little bit more. He now lives in Brisbane, so it's nice to have somebody from a little north out of Sydney be part of the group. So thank you again, Ian, for all the work you've done, and I'm now going to turn it over to you.
Thank you so much, Dennis, and good day, everyone from Mianjin, Brisbane, the land of the Turrbal and Yagara people. It's our honor and privilege to have Randall Antonio present to us today and have a conversation around electric vehicles. Randall is a visionary leader and a dynamic force in the world of digital transformation and disruptive technologies, having held executive roles in North America and the Asia-Pacific region. As a partner at Ernst Young, Randall has masterminded pioneering strategies in artificial intelligence, data analytics, and digital innovation, driving revolutionary advancements for top-tier multinational corporations. His exceptional expertise has garnered him global recognition, including being celebrated as a distinguished intellectual asset by Lockheed Martin. In his early career, Randall worked with Mercedes-Benz and Lamborghini while he was in the US, helping these companies develop technology interfaces that we now see every day in our cars. As a top tier 1 supplier, he also worked with the Volkswagen Group to develop ADAS, the Advanced Driver Assistance Systems, that enables autopilot, self-park, and lane assist capabilities found on Audis, Porsches, Bentleys, and Lamborghinis. On electric vehicles, he also led engineers for the development of onboard change controllers and power control systems. Randall's career journey encompasses roles across aerospace, automotive, and advanced manufacturing industries, and now serves as country chief executive for Dyson Electronics in Asia, leading the organization's engineering, research, development, design, software, robotics, and advanced manufacturing operations for key product lines. In fact, he's overseeing around 12,000 people in the region. So without further ado, it's my pleasure and privilege to introduce to you today our Walter Westman speaker for 2025, Randall Antonio. Over to you, Randall.
Thank you, Ian. Let me share my screen so I would have um, the screen ready for you and I will start talking. Um, just confirming that you have my screen available.
Yep, we can see it, but it's not yet the presenter's view. There you go, Randall. It's good.
Good afternoon, good evening. Good day to everyone all around the world. I'm happy to be here. And I am here to give you a balanced look about the environmental impact of electric vehicles, which not only looks at Australia, but also the rest of the world. Again, my name is Randall Antonio, and I'm currently serving as a country chief executive for Dyson Electronics, the UK-based company known for its floor care, hair care, and environmental products. I am responsible for Dyson's $350 million investment in the Philippines that houses around 12,000 people working on research and development, software, artificial intelligence, robotics, advanced manufacturing, and design and engineering. In this lecture, I will talk about electric vehicles from the lens of a car fanatic. And as an EV owner who also spent many years in the last 2 decades helping develop technology solutions for industry leaders in the mobility space. I will be using my technical background and experience as a consumer and corporate leader to deliver my unbiased view of electric vehicles. We will briefly look at the types of electric vehicles, EV chargers, and EV topics that are relevant to the presentation. Let us first get an understanding of the basics. For the purposes of this session, let's define an electric vehicle as a vehicle that incorporates an electric drive motor that is powered by a rechargeable battery pack. We will focus on the 4 most common system architecture used in electric vehicles. From left to right, mild hybrids are those cars that use an electric motor to help move the car from a standstill. It has a very small battery pack. Hybrids are those cars that have an electric motor that works together with an internal combustion engine called ICE, while the ICE is more dominant with the capability to fully charge the batteries. Hybrids can also drive in full electric mode, but they only have an electric range of about 5 kilometers or less. Plug-in hybrids are those hybrids with a bit larger battery pack, giving them more range in electric mode. Unlike the standard hybrid, where the ICE is more dominant, the electric motor are the more dominant drive system, but they need to be charged externally. They have an electric range of less than 100 kilometers. The most common ones are the battery electric vehicles that are called the true EVs. They have very large battery packs and rely purely on electric motors for propulsion. Their range average about 400 kilometers using today's standard platforms and technologies. When it comes to charging, it is equally important to understand that battery packs operate on the principles of direct current, meaning batteries have a positive and a negative terminal. Charging is a process of delivering electrical energy from a power source to a battery pack. This is what we do with our laptops, mobile phones, and other electronic devices using what we call power banks, power supplies, or phone chargers. Nevertheless, and specific to EVs, the technical term is EVSE, or Electric Vehicle Supply Equipment. We must understand that EVs can charge from EVSEs using either alternating current or AC or direct current called DC. Regardless, all EVs have an onboard charge controller to handle AC charging. The charge controller converts AC coming in into DC or direct current, mainly because the battery packs in our electric vehicles, again, run on DC. But when EVs are connected to DC chargers, the onboard charge controllers are bypassed, allowing higher charging rates that shorten the time to charge. If you look at the chart, there's a box in red that shows you the most common chargers that we use. We label them as level 2 and level 3. Level 2 are the chargers that car manufacturers and car dealers install at your home to charge your electric vehicle. They normally have a maximum output of 22 kilowatts, while for level 3 charging systems, those are the chargers that we see in public streets, and they are capable of up to 350 kilowatts and can charge in a shorter amount of time.
Randall, you're muted.
Apologies. Now it's time to talk about the EV topics of interest, mainly focusing on production, which covers the chemicals, the materials, and the things that are used to build an EV. And the questions behind those will be focusing on mining, processing, and recycling. We also talk about consumption, meaning when we use them on the roads. So we need to talk about power generation, power grid readiness, battery damage, and fire safety. Then after we use those vehicles as consumers, what do they end up in? We will talk about repurposing, recycling, and fire safety as well. And then the most untouched topic when people talk about EVs is the privacy. We have to keep in mind that electric vehicles use a lot of data to function and operate safely, and that information is transmitted to and from the cloud to your vehicle and vice versa. So there are concerns about cybersecurity, monitoring, and control. Let's focus on the batteries for a moment. There are many different battery technologies available on the market, but all of them have one thing in common: the chemicals or the elements. They're mainly lithium, nickel, cobalt, and manganese. They are the main ingredients, and they are mined from different places of the world. China is currently the dominant country when it comes to developing the battery chemistries, and as a result, they are also the leaders when it comes to battery manufacturing and ultimately electric vehicles. It is important to understand that mining plays a big role in creating one electric vehicle and putting that electric vehicle on the road. The biggest and major chemical element in modern batteries is lithium. I am showing you information derived from the US Geological Survey back in 2023, which focuses on the estimated reserves and the amount of lithium that we're extracting from those locations, which effectively would let us know how many more or less years they have left in those mines. I highlighted here Australia as an example. The estimated reserves for Australia is about 4.8 million metric tons. And at the rate that Australia is mining them at 86 million metric tons per year, Australia has about 56 years of mining life left in those Australian mines. Now compare that to the other ones such as Chile and Canada. They have much larger estimated reserves, but on the flip side, their extraction is also a bit low. So their number of years in terms of lifespan is much longer. So these are the things that a lot of companies look at when it comes to pricing the cost of lithium, which eventually ends up in the prices of the batteries and then ultimately in the cars that we buy. Now, mining Australia is a very good example of how a mine should be responsibly how a mine should be responsibly run. This is to show the expanse of what a lithium mine typically looks like. Take note of the scale and the magnitude of the work that exists to extract minerals from the ground underneath us. Then imagine the impact to the environment after the last economically viable amount of material is hauled out of this location. As I've mentioned, Australian mines are a very good example because first world countries like Australia have strict regulations and laws that apply to mining. They also use modern equipment and technologies to keep people safe and our environment protected. The government ensures that post-production of these mines, that the same companies that exploited these mines are the same companies that would try to restore them in the best way possible. I'd like to take a moment here and have you look at this picture. And if I switch to the next slide, you could now compare that on how the same minerals and chemicals are extracted from overseas. It is a totally different scenario in less developed countries. There is complete disregard for environment. There is child or forced labor. And most of the time, there are cartels and corruption that are happening. So when you look at the comparison, it is easy to understand that when these same earth materials are extracted from countries that are less developed, there is total disregard to restoration and proper management of how these mines should be run. Electric vehicles are about 60% batteries when it comes to systems. And fortunately, batteries are very good candidates for recycling. But what is recycling? Recycling, in its broadest term, helps protect the environment. It conserves natural resources and reduces waste. It reduces pollution and keeps harmful materials from our landfills and water sources. In batteries, this is critically important because of the toxic chemicals that make them. It also saves energy, reduces greenhouse gases, emissions, it prevents fire hazards, and supports a circular economy. As mentioned, EV batteries are in a way very recycle friendly, and they are recycled differently. Since batteries deteriorate each time it is charged, an EV battery pack reaches a certain point when it can only hold so much charge and range on the vehicle that it's attached to is affected. This is typically around 70 to 80% of its capacity. Unlike mobile phones, EV batteries have to maintain that 70 to 80% rating before it actually becomes unusable or impractical for use because your range is significantly affected. But this does not mean that the EV battery packs are not usable anymore. They are, in fact, a very good candidate for what is known as a second life use. Their residual capacity, the 70 to 80%, that value might still be suitable for energy storage for solar panels at home, electrical grid storage, or perhaps emergency backup power for buildings. They can also be used for powering streetlights and electrification of other vehicles such as forklifts and hybrid boats, where range is not that big of an issue. In some cases, they can be refabricated before they're totally salvaged for the chemicals they contain. And in some cases, only problem cells are replaced and the battery packs are able to recover usable capacity as refurbished battery packs. Now, we've talked about electric vehicles, the things that go in them, how they run and operate, how they're recycled. I want to also talk about another topic which is important because once you put electric vehicles on the road, the infrastructure plays a critical part on them as well. Specific to EVs, I will talk about energy sources, power distribution, the road network, the safety support systems, and perhaps the social impact of what an EV might bring. In Australia, and similar to other countries, there is a mix of fossil fuels and renewable energy. To Australia, fossil fuels represent about 68% of the energy mix. And we need to understand that EVs need a source of energy to recharge any battery. They have a very large battery pack that are typically around 100 kilowatt hours in capacity. This means that you will need the same amount of externally sourced power to fully charge its battery pack. Unless you charge your EV purely using solar panels at home, even when you plug them into your power points or power outlets, without a solar panel at home, in Australia, 68% of the grid power will still charge that car using fossil fuels, and your EV is able to reach a point that it's in a way questionable if that makes practical sense, or does it make reasonable sense to use a hybrid setup when charging them at home. Talking about the Australian home, I also gathered information that an average Australian home with 3 people in them uses an average daily consumption of about 18 kilowatt hours. That's a full day of air conditioning use, refrigerator use, cooktops, and everything else in the home that runs on electricity. On the flip side, even when you have an EV charger, typically what you will have at home is a single phase wall box, which is more or less about 7.2 kilowatts. Now let's have a look into the average Australian home with a family of 3 that uses around 18 kilowatt hours per day. And compare that to the standard level 2 wall charger at home, which is 7.2 kilowatts. That wall charger will draw in a little over 2 hours what a family of 3 would use in an entire day. Think about that for a moment. Then let's extrapolate that and assume that your EV, with its 100 kilowatt hour battery, comes home with a 30% state of charge, or what we call leftover juice, and charging that back to 80% will need about 50 kilowatts of power. If that is connected to your 7.2 kilowatt charger at home without solar panels, it will take around 7 hours using fossil fuels and renewable mix to bring that back to 80% state of charge. That amount of power drawn by the EV in that 7 hours would have supported a family of 3 around 2.75 days of power. Now let's try to imagine if more and more households without solar panels use an EV charger at home that draw directly from the power grid. It is easy to envision that the power transformers and the transmission cables that have been delivering and servicing those homes electricity for decades were designed for maybe just a family now has the potential of getting overloaded. The other topic would be your Australian roads. Austroads, the government agency, published a Austroads Pavement Technology booklet, Part 8, for construction of these roads. It defines exactly how that road should be constructed for a single lane or a double lane. But that document goes back a long, long time ago when the average passenger car weighed around 1,800 to 2,200 kilograms. Now comes your electric vehicles. Because of the batteries, those batteries add another 1,100 kilograms to the weight of a normal car. What that means is that it puts 2.5 times more stress on road pavements. That's why we end up with more potholes and damaged roads. EV tires and brakes also wear out much faster, and the combination of the tire, the road, and the brake wear results in about 2,000 times more particulate pollution from an EV compared to your regular vehicle. Thermal runaway is another concern. It's a problem of electric vehicle batteries because of the unstable chemicals that are in them or chemistries that are in them. Thermal runaway is a self-sustaining reaction where excessive heat leads to uncontrollable temperature rise, causing the battery to overheat, catch fire, or even explode. This occurs when the heat generation inside the battery exceeds its ability to dissipate heat. Thermal runaway can be caused by overcharging, overheating, short circuits, physical damage, manufacturing defects, and aging and degradation. There are a lot of establishments nowadays in Australia and overseas that limit or prevent electric vehicles from entering underground parking garages for this main reason. Fire suppression systems that we have today, even those coming from the fire trucks, are not up to speed when these things happen. Other considerations that I'd like to add are we produce about 25% more CO2 to produce one electric vehicle. And from a social perspective, you can see on the picture on the right that in other countries, in less developed countries, it is very difficult to imagine what it will be like to be a part of that ecosystem if there are no rules, no regulations, and no policies regulating what the mining process and everything else that revolves around it to the social, to the people, to the environment, and to all other things that revolve around it. But why do people buy, or why do people keep buying electric vehicles? From a buyer's point of view, Number one, environmental concerns. Media, the government, and everybody else have a valid belief that we do have environmental concerns that can be partially resolved by electric vehicles. Of course, the less fossil fuel cars or ICE or internal combustion engines we have on the road, the cleaner the air would be, and the lesser we will be dependent on fossil fuels. Total cost of ownership. It is cheaper to own an electric vehicle. An internal combustion engine needs about 11,000 components to make that one internal combustion engine move an inch from where it is sitting. In an electric vehicle, there's only about 111 components required to move that same thing 1 inch from where it is standing. It is also cheaper when it comes to cost per kilometer. This is very obvious because electricity is cheaper and petrol is much more expensive. As a benchmark, if you were to travel 400 kilometers on a typical EV, that would more or less cost you about maybe 15 Australian dollars in today's pricing. And if you were to travel that same 400 kilometers on a 2-liter small engine, internal combustion engine petrol car, that would probably cost you around 100 Australian dollars. There are also government incentives that drive buyer interest. Government incentives apply to electric vehicles when they have campaigns or programs that offer the buyers rebates. Nevertheless, there are also government incentives that are given to car manufacturers to produce more electric vehicles, and to the consumer, like the buyers and the owners of these electric vehicles. There are government incentives when it comes to registration and licensing. For most people, technological advancements is one of the major reasons why they like an EV. I'd like to think of an EV like a mobile phone that has wheels on it. It is not a traditional car in my mind. For that reason, it is driven by software. It is driven by hardware. In order to give you that amazing experience of the touchscreens, the safety systems, and all other things that excite people from an interaction point of view. Performance and driving experience are also night and day. You have 100% torque delivery the moment you step on the accelerator on an EV. An internal combustion engine has computers that has to take a few microseconds to think about what you're trying to do before it responds and sends that signal to the engine to deliver that power to the tires and eventually to the road. They also want to future-proof an investment because they believe that EVs are here to stay. Internal combustion engines are on their way out. If you notice in the last 2 years, very aggressive campaigns were being done that by 2025, by 2027, or 2030, or 2040, there will be no more internal combustion engine production out of the manufacturer production lines. Then you also have the corporate social responsibility aspect. People think that if they drive an EV, they're contributing something that helps also companies achieve the requirements of government to stay compliant. And most of all, as related to the technological advancements, as more of these technologies come into play, more and more models become available for electric vehicles. So that's a buyer point of view. But there are key concerns. When I started my presentation, I hinted on data privacy and system security. Your EV is like your mobile phone. It has a lot of information about yourself, the way you drive, your behavior, where you go, what you do, and it could create a pattern of your behavior, and it could create that pattern and develop a profile that is usable to other companies. Sadly, all that information is extracted and delivered to the cloud for the manufacturers to understand what they need to improve on the vehicle, but sometimes that information is abused. You also have higher risk of total loss or write-off. Um, there have been instances where an EV drove a little bit too fast over a speed bump, scraped the undercarriage, damaged the frame or case that holds the battery. And since it was dented, the entire battery had to be replaced. And replacing the entire battery pack on an EV is about 60 to 70% of the cost of a brand new EV altogether. Because of those issues, there are also concerns about year-on-year price drops. If you were to buy an internal combustion engine today with a similar model in an electric vehicle, by next year, your internal combustion engine would or may have dropped about 20%. Your EV value may have dropped 30 to 40%. Then there are concerns about material recycling because we don't know exactly the eventual impact of a larger volume of EVs coming offline, coming off the road. We don't know if we can handle that or if companies are capable or have the capacity to handle those, which in turn gives an uncertainty of how EVs will really impact the environment in the long run. EVs could be a transitory solution to alternative fuels, such as hydrogen fuel cells. Dennis and I had a little chat earlier about it. And because of technologies that are coming up, trying to beat the EV technologies that are in the market, we may realize at a point in time that other propulsion systems on vehicles might be better and could be better than an electric vehicle. Obviously, when electric vehicles get damaged, the cost of repair is much more expensive, which makes their insurance premiums much higher. And since there's not that many of them, relatively speaking, on the road, and there's so many variants and different models that are entering the market, parts availability is an issue. And if you have to resell your vehicle, resale value becomes an issue. So the big question, should we or should we not go electric? I've thought about this in a bit, and I figured that I would lay out some stay indicators. I'd like to argue that third-party efforts are on the high gear for the things that we worry about. Manufacturers are working hard to improve everything that goes into an electric vehicle. And governments are pushing EV adoption, providing subsidies. They're investing significantly in charging infrastructures. They're improving policies, standards, and regulation. And they're concerned of its impact to our natural resources and environment. Now I'd like to walk you through a very interesting comparison between a petrol and an electric model of the same car. In this case, it's a 2024 BMW X3 platform. The petrol version is commercially known as the S-Drive 20i, and the electric version counterpart is known as the iX3M Sport. Both cars are within a few $1,000s of each other. But if you can look at the box in red numbers, what you have is a glaring difference of how much better an EV is in relation to our environment. You also have to look at the 5-year carbon footprint after it is produced and used on the road. A petrol version of that same car would have released about 26.51 tons of carbon or CO2, while the electric vehicle would have produced about 17.46 tons in total over 5 years. The assumptions here are petrol is $2.09 per liter, and electricity is pegged at around 19 cents per kilowatt hour, with an annual distance traveled of about 12,000 kilometers. This is Australian data. Now, I come to my last slide to provide my opinion. Those listed in black are my positives. To start, environmental and health benefits inside of population centers become better when you have less pollution coming out of tailpipes. EVs are more energy efficient because they convert up to 77% of the electrical energy compared to petrol, which only 20% in that petrol fuel energy is used in moving that car from a standstill. We also reduce our dependence on fossil fuel. We're talking about crude oil, coal, and natural gas. And then EVs also has a broader advancement in energy storage and smart grid technologies, including innovation in batteries, energy management, and renewable energy integration. There was, I believe, a case in, if I'm not mistaken, Australia or mainly specifically Brisbane, when the typhoon hit, one household was able to continue running a life support system even after the power grid was cut off, and the home was able to use the energy that was stored in the electric vehicle, feeding back into the house to power the life support system, thus saving a life. And most important of all, EVs are more convenient to maintain and operate. On the flip side, as we bring more EVs and produce more EVs, we will mine more and more precious metals, and that may lead to exploitation. Insurance will keep on rising because of the expensive costs to repair when EVs are damaged to itself and to others. Minor dents on the battery pack, something I mentioned earlier, requires a complete replacement. And data shows that 9 out of every 10 EVs are written off just because of this. And the last one in my list is privacy, cybersecurity, and hacking risks. It is a mobile phone on wheels, so data is on the cloud, and for as long as it's connected to the internet, we don't know what risks we face. That ends my presentation. Thank you, and I'm open to having your questions answered.
Thank you so much, Randall, for that presentation. We have Von Pratt who has written something on the chat box. I thought EV's brake wear was much less than ICE cars due to most braking being done using regeneration. Is there anything you'd like to say in respect of that?
That's a little bit subjective. Regeneration is very prominent on specific cars and specific cars only. And I think when we talk about regen, the first car brand that comes to mind is Tesla. Tesla is very big on regen technology because they believe that it's the way to go. But for those other cars, the traditional cars with heritage brands such as Audi, BMW, and the likes, regen is an option that you just enable and disable on the vehicle. The way that purists of the car drivers of the Audis, BMWs, and these brands like to maintain that drive and feel of your internal combustion engine, which means that they dislike the feeling of regen. So for those cars, Tesla, yes, you have less brake wear, but for other cars, there's more brake wear, as the data suggests.
Okay, thank you. The table's now, or the floor is now open for questions from people. Maybe to kick things off, I'll ask you a question, Randall. You've been involved in the automotive industry for a long time. You're very passionate about cars. I mean, if there's someone I know who talk about cars for days or weeks, it would be you. You are a car enthusiast yourself. Like, what was it that encouraged you to get into EVs yourself? Because when I met you, you were still not sure, right? But from what I know now, you have pretty much bought 3 EVs yourself. Would you like to share your thoughts on that?
Absolutely. As a car fanatic since I was young, I was also passionate about technology. I'm an electronics and communications engineer by coursework, and I do like innovation, technology advancement, and practically gadgets for the most part. So when we were trying to justify and we were trying to understand what it would be like to drive an EV, frankly speaking, I started looking at EVs all the way back in 2008, 2009, when the Nissan Leaf and the BMW i3 and the i8 was introduced to the market. I understood from the limited knowledge that I know that it wasn't mature yet or mature enough at that point in time. So I decided to wait and continued to monitor the advancement of AI, which was in 2018, when what we know now as ChatGPT was in its infancy stage. And when all of those things started to happen, and when all of those things started to come together and found its place in a car, it made the cars a lot safer. It made the cars more practical. It made the cars more efficient. That became the trigger in 2021, if you remember, Ian, that I bought my first EV. It was a 2021 mild hybrid Audi. Then in experiencing that Audi, I realized I really liked the way it drove. In 2022, I bought the iX3 and then loved the way that drove. So I wanted to try the other car that was known, that's more popular, which is the Tesla. And today in the Philippines, I drive the Audi Q8, which is a full battery electric flagship line. So it was mainly driven by the interest in technology, innovation, safety, and efficiency overall, and ultimately the experience that I get. So quiet, so responsive, and it's so much a pleasure to drive. Hope that answers your question.
Good. No, thank you. Um, the floor is now open for people either to type their questions on the chat box or raise your hand if you have questions or points you'd like to share.
Yeah, so this is Dennis again. I'd asked this a little bit earlier when we were talking, but I'm thinking about hydrogen cars. You just barely mentioned it, and we talked about the environmental impact of it, but I wondered how viable they are. When there's such a move towards EV, is there really a market or an ability to really move towards hydrogen after setting up all the charging stations and so on?
Yeah, to answer that question, that was the same question I probably would have gotten when internal combustion engines were being introduced way back in the early 1900s. It will be the same question that I will be getting when they were introducing electric vehicles about 10, 20 years ago. And maybe for the right and same reasons, it is being asked about hydrogen and other alternative fuel sources for vehicles. The answer lies on the infrastructure. It is a chicken and egg scenario. Which one comes first, the chicken or the egg? When the petrol or the internal combustion engine vehicles came into the market, everybody knew that they need a way to supply these vehicles with fuel. The difference between now and then was that petrol was easy to get from the ground, was easy to process, and it was fairly easy to distribute to different locations where people could gas up and fuel their cars. The EVs are a different story. The EVs are now, in a way, matured in many countries, mostly first world, the US, the UK, Australia. In the US, I think there are about 50,000 plus charging stations. In Australia, there's about, I think, 5,300 the last time I checked from the data that I have. That goes on for the entire country. And needless to say, there's still a long way to go, mainly because they are requiring a different set of setup. They require different type of infrastructure to support. And it's not easy to get power from one place to a remote location if you're traveling interstate. I think that would be more difficult when it comes to hydrogen fuel cells because the investment is expensive. People are not sure yet, although it is a more viable solution in my mind and in my opinion only, that it's a more viable solution compared to a battery electric vehicle in terms of overall experience. Hydrogen fuel cells will run through the same process as finding the right infrastructures and having the right people invest in those infrastructures before they become mainstream. Hopefully I answered your question, Dennis. But I think moving forward, any alternative fuel vehicle that will enter the market today will go through the same pain point, that it is hard to understand its future unless you have the infrastructure investments in place.
Okay. Dennis, you're okay with that? You happy
Yes,
with that?
thank you. Yeah, thank you.
Okay. Randall, we have a few questions or comments on the chat box. So I'll just read out the first one from Rod. Road pricing for EVs has not been advanced by government fully. Have you got any thoughts on how this should be implemented? At the moment, petrol cars pay road excise, whereas EVs are using the amenity at no cost.
Um, it's more of a subjective topic because it depends on which country you're in. In the Philippines, where I am at right now, we do pay the same road taxes that we pay for petrols and EVs. They're the same. It doesn't matter. We just get some type of exemption from certain restrictions that we have on the road that are not existing in other countries when you have an EV. In Australia, I think Victoria um, tried to implement the annual 4 cents or 2 cents tax on every kilometer that you drive when you're using an EV to pay for those road taxes. Nevertheless, I think that didn't pass and then it was retracted. I'm not sure about other countries specifically, but that I think would depend on regulation and the philosophy of those people who are sitting in the policy making boards to figure out what to do and what is best for where they live.
Okay. Thank you, Randall, and I hope, Rod, that answers the question or feedback you have. We have another point here from Von Pratt. I thought all EVs use regen when the brake pedal is pressed. My wife and I have been driving EVs since 2016, and our brakes show no perceptible wear. What's this? We've had a Toyota Mirai FCEV, two Chevy Bolt EVs, a Lyric EV, and I'm converting my DeLorean to EV. That's his comment. Any thoughts there, Randall?
Yeah, in its technical definition, regen is the process by which the moment you let go of the accelerator pedal, the motor starts operating in reverse and your inverters and your control systems, rather than sending power to the motor, takes energy from the motor and puts it back to the battery. It has nothing to do with stepping on the brake or the brake system. So in Teslas, as an example, the moment you release your foot from the pedal, you will feel that car slow down, or you'll feel some type of um, pushback from what seems to be a brake pad gripping your brake rotors. I am not sure about the exact thing, but if you do have regen on your car activated, which we can activate on the mainstream cars that I mentioned, yes, you will have less brake wear. I do fully agree with that. The only difference there is, as mentioned, not all cars benefit from EV, and that is a user choice that is dependent on the owner that's driving it.
Thank you. We have another comment here. Thank you from Greg Hausman. Thank you for a very interesting survey of EVs. On the point of data security, it seems the same issues will arise in the petrol vehicle also. And actually, the data leakage from the mobile phone we carry is probably much greater. Just a comment. Any thoughts you want to share, Randall, on that point?
Yeah. EVs were the first ones to really pick up on collecting data and sending data to the cloud. Petrol and your ICE vehicles are now catching up. But if you were to compare two vehicles, let's say the cars that I compared earlier, which are both of the same platform, one is an EV and one is a petrol, there are more data collection points for some reason on the EV version of that vehicle. And yes, I agree that the phone that we carry has more greater data, but again, different purpose, different use. The risk exists in both platforms.
Okay, thank you. Another comment from Vaughn, who gave a comment around regen earlier. No, Randall is talking about one pedal driving. All EVs use regen when the brake pedal is pressed.
Okay. I guess it's a it's subjective because different manufacturers also use different terminologies. One pedal driving is in part regen, yes, but on other cars such as the Audis that I've owned and driven, I can turn off one pedal driving, and same is true with the BMW. But that forces me to use my brakes, and it's a choice that I can make immediately by telling the car not to use regen at all completely. But for sure, yes, I agree that if you do use one pedal driving, yes, regen is available and functions the way it's expected to do.
Cool. We have no further comments on the chat box, but I'd like to know if there are any questions from the audience. Feel free to raise your hand and we can ask Randall to answer those.
Well, can I raise something?
Sure.
Yeah. So my wife has absolutely refused to use one pedal driving for the 8 years that she's been driving an electric vehicle. So she never uses one pedal driving. But our the Bolt EV that she drives has absolutely no brake wear. And the reason for that is that when she presses the brake pedal, the regen kicks in, even though she's not using one pedal driving. One pedal driving has nothing to do with this.
Yeah, well, again, the reason why you call it one pedal driving is because when you let go of the accelerator pedal, the motor starts stopping your vehicle. When the motor starts stopping your vehicle, that is because of the energy forces that are happening between the magnets of the motor and the coils of the motor. And when those two things interact in the opposite direction, it tries the magnets tries to stop the armature, which in turn creates electricity that is fed back to the battery system.
Except that she doesn't use one pedal driving.
Yes. So when you when you use your brake pedal, and if it makes you stop by way of regen, that
Yes.
is also one way of telling the motor to recharge the vehicle. That by itself is a software setting that can be set, or maybe in that particular vehicle cannot be set.
Cannot be set in her vehicle.
Correct. Yes, it is a function or a feature that's enabled and activated on the vehicle.
That's why she has no brake wear on her car.
Yes. So if there is a way to find that feature, if you want to turn off regen, because sometimes it's really annoying, right? If you turn off that feature, your car will function just like any other petrol car, where you let go of the pedal, you will still continue coasting until it finally loses momentum to the point that it stops. As opposed to letting go of the pedal, stepping on the brake, and then the brake pads don't really grip, but the electric motors start holding back the momentum until it comes to a point where you also need to press harder and put the car to a full stop. So that's why
But
you have
there's
less.
no point. There is no point where she can. You can't turn off regen on her car. You're just confusing one pedal driving with regen. Regen happens when you hit the brake pedal. All that one pedal driving does is it turns on regen when you lift your foot off the accelerator.
Correct. But to that same argument, yes, the moment you release your foot from the accelerator, regen kicks in. That's why it's one pedal driving.
Yeah,
As
but we're not
opposed,
talking about one pedal driving. We're talking about hitting the brake pedal. You hit the brake pedal, and there's no the brakes don't come on. The regen kicks in.
okay, yeah. So yes, so when you okay, the difference there is in most cars, when you let go of the brake pedal, regen kicks in automatically because of a setting. In your case, the way that the manufacturer probably designed your car is that when you let go of the brake pedal, regen doesn't hit or kick in until you step on the brake pedal, and regen kicks in to help stop or decelerate your vehicle.
Right.
So it's a setting in software on the control systems that's on the vehicle. That's probably by design by the manufacturer for that brand and for that car to be that way. In many other cars today, they do have those features that you can activate one pedal driving, regen, or regen by way of brake pedal, or no regen at all.
So are you saying that on the Leaf, the hitting the brake pedal does not cause regen?
I am not familiar with the Leaf. All I am saying is, at least for the cars that I drive and I own, I can turn region on or off based on the accelerator, based on the brake pedal, or totally turn it off.
Yeah,
And
that
with
that would be one pedal driving that you're turning on or off.
when one pedal driving is either you're moving forward or you're being decelerated, correct?
One pedal driving is when you use the accelerator to control the braking.
One pedal, that's the same thing as if you were to press on a pedal and the motors or the regen aids in helping to stop your vehicle. But it's
Okay,
a
well, anyway, good.
Yeah.
Let's leave it at that.
Yeah. Okay. Look, if there's interest in continuing this offline, we can do that. Personally, I've learned a few things today. For me personally, the verdict is still out there if I would go the EV way or not. I learned a few more things, additional data points. So I will continue to contemplate if this is EV is the route for me or not at this point in my life. I'm sure that one day the next vehicle that I would buy would be an EV, but again, for me, I'm still contemplating. Thank you so much, Randall, for your time today. And I hope our participants from all over the world, I know that some people have joined us from Singapore, some people have joined us from different parts of Australia, some have also joined from other parts of Asia. We do appreciate you joining us today, also from the US. If there are other questions, feel free to send a note to Dennis or I. But if again there's a more passionate conversation about this one, we're more than happy to have a chat with Randall. I personally don't understand what you were talking about. It goes to show my level of interest in cars. Um, but you know, I love the passion that you both showed for today. So on that note, thank you very much for attending Walter Westman Lecture 2025. Dennis, I'll pass on to you for any closing words that you may have.
Thank you, Ian. Let me also thank Randall and the nice conversations that we had, discussion, and thank you to Ian for organizing this. And I'm going to now stop the recording